Number 10 from the Chapter 7 homework. This problem reads that Atlas Home Supply has paid a constant annual dividend of $2.40 a share for the past 15 years. Yesterday, the firm announced that the dividend will increase next year by 10% and will stay at that level through year 3, after which time the dividend will increase by 2% annually. The required return on the stock is 12%. What is the current value per share? Okay, so this is almost the exact same game that we played with number 2. The difference is, rather than the dividend being constant after a period, being just a set level amount, it's going to have a set growth rate. So it's going to increase each year, but it's going to increase by the same amount each year. And that allows us to still calculate the present value of it with a nice clean formula. It's just a little bit different than the present value of a perpetuity. Hey, but we're going to go through the exact same steps. We're going to have the first 3 years here are going to be a level dividend, and then starting in year 4, it's going to grow by 2% each year. So we're going to have to break it down just like we did with problem 2. We're just going to throw a little bit different formula at it right here. Okay, so but the first step is to map everything out in the timeline to make sure you get your cash flows happening at the right period. So it's been paying that $2.40 a share for the past 15 years, and that's what would have happened here at time period 0. But next year, at the end of year 1, the dividend that we're going to receive is expected to be 10% higher than that $2.40 that they've been paying. So what we do to find the dividend at the end of year 1 was take that 2.4, that $2.40, times 1 plus our growth rate, or 1 plus 0.1. Okay, so that's 2.4 times 1.1, and that just makes the dividend 10% higher than it was. Okay, and we find that that's 2.64. So we're expecting to receive a dividend of $2.64 at the end of year 1. Okay. And what the problem tells us is that it's going to stay level through year 3, after which the dividends will increase by 2% annually. So rather than changing on us for the next 2 years, it's going to be 2.64 in year 2, and at the end of year 3, 2.64, it says through the end of year 3, we'll receive that $2.64 at the end of year 3. But then starting in year 4, it's going to increase by 2%, and then it's going to increase by 2% every year thereafter. Okay, so in year 4, we have a little bit of a change here. We're going to take that 2.64 that we received at the end of year 3 times 1 plus our growth rate of 0.02 here. So 2.64 times 1.02 is 2.6928. Okay, and that's our dividend that we expect to receive at the end of year 4. At the end of year 5, we're going to take this year 4 dividend and again grow it by 2%, so 2.6928 times 1.02. We find that's 2.7467, and then that's going to continue to grow, just dot, dot, dot. It's going to go on, going up 2% each year for the rest of the foreseeable future, into infinity as far as we're concerned. Okay, but we have a formula that we can apply right here and find the present value of this thing, given that the growth rate is constant. Okay, but what we'll do first is, just like we did in problem 2, we'll find the present value of our first 3 years right here. Okay, and since these are level cash payments, you can either use the time value keys on the calculator, or you can use the cash flow menu if you want to. In fact, that actually would have been a little bit quicker now that I'm sitting here thinking about it. Talking about this problem, you could have just entered the 2.64 once, and frequency is 3, and found the present value. But whichever way you're more comfortable with it, I chose to go after it with the time value keys when I did the solutions here. If you do it this way, your N is going to be 3. Your interest rate is your discount rate, which is our required rate of return on the stock. That's 12%. Present value is what we're looking for, so you'd skip over that. The payment is $264. That's what you'll receive at the end of each year for 3 years. And then your future value is going to be 0. So you'll just compute the present value and find that it's 6.3408. Okay, so that's the present value of these first 3 dividends right here. Okay, we'll either write that down or store it in the calculator somewhere and set it aside. Now what we want to do is apply a formula here to the dividend we expect to receive at the end of year 4. We're going to find the present value of this constant growth dividend. But similar to the present value of a perpetuity, when we apply this formula, it's going to give us the present value of all those future dividends just 1 period back. So when we apply that formula to time period 4 here, it's going to give us the present value 1 year earlier. It's going to give us the present value as it would be at the end of year 3. So after we find that number, we still have to discount it back 3 years to get it to time period 0, to be able to add all these guys up. And so, but the first step is to find the present value of that constant growth dividend. And the formula is very similar here to what our perpetuity was, But now we're going to do the required rate of return minus the growth rate in the denominator rather than just the required rate of return. Okay? And I encourage you to go back and look at page 206 and kind of read what's going on there and get a feel for what's happening. Okay, but again, I put the subscripts on here to match the problem. In the text, you'll see P0 equals D1 or DT plus 1 to mean the dividend 1 period from the time that you're calculating the present value. Okay, but for here, we're taking dividend 4 at the end of year 4 right here. Okay, and so the book will call this DT plus 1 or D1, one of the two. I think the formula is T plus 1 in the book. Okay, that's going to be dividend 4 for us, divided by our required rate of return, which in this problem is going to be 12%, minus our growth rate. Now, this is our constant growth rate for a constant growth stock. So in this problem, it's going to be 2%. That's what we expect the dividend to grow by each year. So when we plug these numbers in for this problem, we take that dividend at the end of year 4 of 2.6928, and we divide it by our required rate of return of 12% minus the growth rate. So that's just going to be divided by 0.1. Now you'll find the present value of that guy is 26.928. But again, that's the present value at the end of year 3. Okay, when we apply that formula right here to this dividend, it gives us the present value 1 year ahead of time. Okay, in this problem, it's giving us the present value at the end of year 3. Now we have to take this number, this 26.928, and again discount it back to time period 0 in order to get to be able to add it to the other present value that we found here. So everything's at time period 0. We're adding apples and apples. Okay, so the next step is to discount that 26.928 by 3 periods. We're just going to take it back 3 periods. So whether you want to use the time value keys in your calculator or just throw the formula at it, whichever one makes more sense to you, you'll get the same number. Okay, I chose to go for the formula, so the 26.928 divided by 1 plus 0.12 raised to the 3. You'll find that's 19.1668. So that's the present value of that constant growth stream of dividends. Now we can take our two present values from step 1 and step 2 and just add them right together because they're both at time period 0. And so the 6.3408 plus the 19.1668 is 25.51. And again, that the interpretation there is that's what we'd be willing to pay for a share of that stock today in order to receive those expected future dividends.